A Canadian one.
I think you should show the shoes off.
Yeah. Stan Smith.
Yeah.
French ones.
Very nice.
From an American basket player. Je trouve quand même inadmissible qu'il y ait des gens qui viennent et qui ne mettent pas de veste par-dessus leur chemise et leur cravate. On va être sérieux quand même. On va être pro. Okay, thank you for all of you for being here. This sixth session will focus on the power of marine bacteria. Marine bacteria are found throughout the oceans, from beaches to estuaries, from lagoons to the seafloor. Far from being a uniform environment, the oceans contain many distinct habitats, such as deep sea sediments or tidal sands. It's the unique survival mechanism that make marine bacteria so promising as a source of new biologically active substances, which potential uses in industries, processing medicines and food. This session will explore the real potential of bacteria for industrial biotechnology, remediation, food and feed, cosmetics, and pharmaceutical application. My name is Jean-Christophe Sergère, and I'm the founder, president, and CEO of Cetubio, a biotech company dedicated to the discovery of innovative compounds for markets such as hygiene, cosmetics, and health. We perform this work using HTS platforms to identify compounds of interest from the whole diversity. And I will be the moderator of this session. Time will be very important, and I will be very attentive to it. 3 panelists here will share this live session with me. The first one, Emmanuel Petiot, is the CEO of Deinov, biotech company based in Montpellier, France. Deinov was created in 2006, listed in 2010 on the European Stock Exchange Euronext, and 48 people work now for Deinov. Guy Veil is the CEO of CRBM, a marine biotechnology center based in Quebec, Canada, and is financially supported in part by Quebec and Canada, right? And CRBM performs research and development on extracts and active molecules of diverse bioresources, including marine ones. The work of CRBM targets companies of the pharmaceutical market, but also nutraceutics or cosmetics. The third one, Jason Kaplan, has a PhD in marine sciences and is the founder, president, and CEO of Ensolve Biosystems. The company is based in Raleigh, North Carolina, so close from here. It provides packaged biotreatment systems for maritime and land-based industries. We will start at the beginning with the oceans as resources of compounds for different applications and market. Emmanuel, you can smile, be happy. This is the last one. You got a huge library of about how much? 6,000 bacterial strains, right? Including 2,500 Deinococcus. Some of these bacteria come from the oceans. Can you tell us about this wonderful library of resources, please?
Yes, thank you, Jean-Christophe. So we have a wide bank of 6,000 candidates. It took us quite a few years actually to collect these strains throughout the planet. We have been in mainland France, you could say, so close to where you live, Jean-Christophe, in Auvergne. We have collected strains in Corsica, in the south of France, wherever you find a hostile environment, and I'll tell you why afterwards. We have also collected strains all over the planet. We have selected some from La Réunion, from Tahiti, and always in hostile environment, because we were thinking that we could find in these places bacteria that have survived to quite a few hostile experiences in a way. We went to 1,215 places, which is quite a lot, 23 campaigns, and we selected them from not exactly the ocean, but from hot springs, from estuaries, from volcanoes, deserts. We also sent or collected some from the stratosphere, so very high up, almost in space. And we collected these strains, and these strains, what we do is when we get a sample, we irradiate the sample, so we select them through irradiation, repeated irradiation, which means that we keep only the most robust bacteria out of these samples. And this is interesting because then what you can extrapolate is from these bacteria, you can extrapolate industrial benefits, and that's what we're trying to develop step by step. One thing which is interesting as well is that these strains have survived on that planet for almost 4 billion years. So these bacteria have fed themselves from their environments, from other plants, other microorganisms, and other pieces of basically their environment, and that's why we can find a very wide biodiversity within all of these strains. So you're right, most of our strains are Deinococcus, which is again impossible to pronounce, so we call them Deinos in the US, and these strains are very specific because we're the only one to exploit them on an industrial basis. And we also have an additional 3,500 other strains that are different genus, not Deinococcus. We have Rhodococcus, we have many other type of bacteria. And the goal for us is to understand what do they produce naturally. So some of them produce carotenoids, and this is due to the fact, and you tell me how long I have, Jean-Christophe, because I can speak for hours. For the moment. Some of these bacteria have, most of them have been irradiated, and when you irradiate a bacteria, they protect themselves, and one of the protection mechanisms is the production of carotenoids. And most of our bacteria have a carotenoid pathway embedded into their genome. So instead of having to build a C40 pathway, which is a pretty tough one to do, you can exploit the natural property of these bacteria to produce carotenoids. These bacteria also produce things like exopolysaccharides, they produce enzymes, and they produce compounds that can be used mostly in feed, food, and cosmetics. So this is what we will do going forward, is understand what type of compounds are being produced. And of course, it sounds easy on a piece of paper, but characterizing exactly what they produce is not always something which we do on our own. So what we do is we strike partnerships with labs that can characterize these molecules, and step by step we try to understand which ones are, of course, technologically sound, so makes sense and can find an application in feed, food, and cosmetics, but also what type of compound can be produced in a cost-efficient manner, because it's one thing to produce a compound, it's another thing to be able to market that compound. And that's what we're doing right now by trying to strike deal with partners who will guide us, towards the right compound.
Okay, so to be clear, you are working on extremophile strains, right? So deep seas, for example, might be of particular interest because of the pressure, because of the salinity, because of the temperature, since there are volcanoes in the deep seas. So do you also plan to enlarge your libraries with those kinds of collections?
It's the difference between diluting your effort and diversifying, so I'm making a difference between the two. We have 6,000 candidates, which is already a lot, to understand. It took us 5 full years to fully structure the bank and to understand what they produce. You know, we took a photo of each of the strains that we grew. We know what type of compound roughly they produce. We know what type of color they can produce. We have a GPS coordinate for each of our strains. They're barcoded. So this takes a long time. We could, on a spot basis, expand our bank. But at this point, I think what we want to do is to explore the biodiversity of what we have today.
Oh, okay. Okay, so once you've collected those strains, you got to screen for different properties, right? Can you tell us about the strategy for screening and how you define the market and thus the tools to reach these markets?
So we have essentially, I think, two approaches. The first one is to say carotenoids is something very special with our bacteria because we have 400 different strains producing 400 different carotenoids. Some we will be able to market, some we will not. But we have decided to do it on our own and to be in a position to identify the best producers and to extract our first batches from these strains. So we're going to do that on our own, and of course, step by step, the more we go through the extraction process, the first batches that are being produced for us, we will not do that. We will work with companies doing it on our behalf because we don't have the equipment. Step by step, we will then strike deals with partners who are interested in seeing the actual product, which is, of course, one of the issues we face all the time is, as a biotech company, everybody asks us, when are you going to sell anything? So step by step, we'll have something very tangible to propose and to sell. The second thing is, because we have a large bank, we also are developing a strategy with partners, and I'm negotiating deals right now, to tell them what we have at a very high level, and then strike a deal and then screen according to their own parameters that we will insert in a kind of a midterm R&D project, a 2 to 3 year R&D project. So it's very much of an upstream R&D exercise, and we do that more on an opportunistic basis with partners. We don't go on our own because we don't know whether this will be successful, and we have a hard time to understand exactly which one will make a difference. But by striking deals with partners, we can guide our R&D towards what you call, commercial products, which is exactly what we want to do.
Okay, so looking for partners, maybe Guy could be, you might be one, who knows. Guy, you also work on resources from the seas, from marine resources. How do you select those resources?
Okay, if you speak about the marine microorganisms, for example, or microorganisms, we select the use of microorganisms based on the request or demand of private customer. Give me an example. Give you an example. For example, we could have a need for a specific enzyme activities, for specific, for example, remediation activities in a clean tech market. So we are looking to find in public bank of microorganisms or the type of bank that you have to find some species of microorganism or genus of microorganism that could answer the request of our customer. And this type of activities, we obtain strains coming worldwide for the same species or the different genus, and we characterize by screening activity. For example, we have in mind a project that we test in industrial prototype this summer, and with the project starting 4 years ago, and we screened for the enzymatic activities at the beginning. We screened for the better production of this, expression of this enzyme activity. It was a microorganism that we could find in marine sediments. And so sometimes we have a question about how to produce that to have the highest density production of this microorganism, to have the enzyme activities or for the final products to be sure that we will answer the cost objective of the private customer for the final product. But we know at the beginning the cost objective of the final products before to put that on the market. So we have a way to screen the activity, multifactorial statistical analysis of shake flask fermentation system to define an industrial medium that will simulate the the original environment, and after that we're able to put that in a 3 liters fermenter and up to, for example, a pilot plant fermenter to produce the microorganism. In this case, the example that I have in mind, we did that up to 40 liters fermenter in 150 liters in the last summer with the highest density we obtained, highest than in the laboratory, and we were able to test in a bioremediation activity in the installation on the private customer. So the need is not from to know exactly what are in the bank. We decide based on the needs of private customer to decide what type of microorganism we will look at the beginning.
Okay, so first of all, I wanted to thank you because you answered to all the questions I listed. That's great. So we can see that there are two different strategies. Once you got your libraries, either you try to valorize your collections, your libraries, or and try to identify some applications, or you do the opposite strategy from the potential market, right?
Yes.
And then
with a specific demand.
Yeah,
Exactly.
on specific demand. Okay. Can you tell us a little bit more about the scale up for the production of your resources, especially for the production of marine resources? Do you have some facilities, some specific?
We have facilities, including quality control of the process since the beginning. That means when we start a process like that, we put in place the methodology necessary to evaluate, for example, enzymatic activities, enzymatic content, quality control, and we start the process in the laboratory. We including analytical microbiology and analytical chemistry, and we are able to put in place new analytical method. For example, in the last summer, the customer used an analytical method that we developed in the center to validate the use of the microorganisms in their installation, because they had to follow a specific organic compounds that the microorganisms work on in. So for that, we have the laboratory, and we have also the pilot scale, including preparation of the feedstock for microorganisms production. That include the fermentation system, and we're also the downstream processing, including centrifugation, ultrafiltration, and we work with some partner in Quebec to increase the scale up of the production up. For example, in this case, it was the last scale up was at 150 liters of fermentation. Yeah.
Okay, so you can grow your you can increase the
Yes.
the volume
Yeah.
throughout partnerships, right?
Yeah, using partnership if necessary. It's very important in view, normally in the industrial microbiology application, to be sure for a question of regulation, we have to follow also exactly the pureté of the strain since the beginning. Pureté based on the microbial contaminants, but the pureté of the strain based on genomic fingerprinting, to be sure that there will have no genetic degenerescence, the diminution or something like that during the production. We put in place the genomic analysis at the beginning also to be sure that we will follow the regulation requirements that could happen after for the marketing commercialization.
Okay, so you talked about the quality control. I suppose, Emmanuel, that you also have your own internal quality control. I mean,
Yes.
throughout the description of the different strains and then the barcodes. I don't know how you follow the strains.
We
how you control
we
them.
don't have a very specific quality system, but we have a very thorough structuring of the bank, and you know, it took us 5 years. So I mean, this is just being organized rather than being certified at this point. But yeah, we follow a very. I mean, we have a dedicated biodiversity department, and when we look for a specific activity or a specific pigment or a specific, I don't know if you want to look at an exopolysaccharide, we go back to the biodiversity people and they can point at the 30 different strains that could potentially be candidate to produce a given product and therefore a functionality for a given industry.
Okay, thank you. So, Jason, you already you have products that are already on the market, and those are very interesting products. Can you tell us a little bit about your resources you valorize?
Yeah, Yeah, thank you. Just to let you guys know what we do, we make biological treatment systems primarily for the maritime industry. We basically take a functional approach to our microorganisms. We get extremophiles throughout the world because we're primarily treating bilge waste from ships, which, believe it or not, is one of the largest sources of oil pollution in the world. So what we've done is we've taken, these ships operate throughout the world. We have some in Europe and North America, Far East, and even as extreme as Antarctica for some krill vessels that we're working with our Norwegian fishing company. So bottom line is we have to have the organisms do two things. One, they have to survive the harsh environment, and they have to function. So they have to essentially deal with the hydrocarbons that they're faced with, because there's strict regulations in the amount of oil that can be discharged from these ships. So essentially we take, it's like the computer, the hardware, which is the device itself, and then the software with the microbes. And so we spend a lot of time in the proper engineering, not of the microbes themselves, because they are natural, but the actual hardware, so they have the maximum ability to degrade the contaminants. We have a very small environment, so we have to pack in a lot of microbes, and they have to do the job. And in most cases, we have to get less than 15 parts per million oil, and in some environments, like Antarctica or the Canadian waters, we have to be 5 parts per million. So that means we have to be, have a really good design to have the most amount of microbes and the right kind of microbes to do the job. So that's one of the products we have. That's an oil water separator. We have a new one that just really is being commercialized right now. It's called N-Scrub. And this technology is dealing with scrubber water. Right now, the shipping industry is faced with dealing with SOx, S-O-X. Everybody probably knows about scrubbers getting rid of SOx from petroleum, but the problem is that converts it to water. It takes it out of the air, but then you've got a water problem. So they've just moved the contaminants from the air to the water, and then our job is, the technology we've helped develop through the National Science Foundation is a device that takes care of that using a combination of physical and biological means of dealing with that waste. So again, heavy concentration in the maritime industry with packaged biological treatment systems.
And can you tell us a little bit about the origin of those microbes that clean everything? Do they come from the academic world or from biotech companies, or did you develop by yourself those microbes?
Yes, we've done all of it. So essentially we've had, the nice thing about our business is that our customers are around the world, so we can get microbes primarily from the bilge themselves. So we're starting with what they've already been exposed to. So from a natural selection, they are already dealing with that waste. We also buy commercial products. You could be we could be a customer of yours. If your bugs can do a better job than our bugs, that's not our business model. So we wouldn't be competing with you. Our business model is the device itself, and then we're like the printer ink cartridge model, where the printer would be the actual device, the biofilter, and then the ink would be the supplies, the nutrients to keep the bugs alive. So we were very open to different types of microbial sources, so we're not tied to our own. We start with those, but if we can enhance that using other suppliers, we're very open to that.
Okay, so this is very interesting. So you assisted to a live connection. Okay, so from all of what I know about your different activities, those resources are very, very promising with standard applications such as cosmetics or health or nutrition, but also for decontamination, depollution of the environment. What we can, I'm just checking the time. That's okay, 5 minutes, Pierre? Great. So to summarize, what is interesting is that there is a scheme that looks very, very classical, very standard from collecting those resources. The interest is the place they come from. You do not collect them on the walls or on the rivers all the time, but they can come from different places, including including polluted sites and so on. It seems clearly that what is important is the screening, right? The way you select all of those microorganisms. If we, what this means, this means that depending on the markets you target, you got to develop tools, and from one kind of library, you can bring them on different roads to bring them to the market. So it depends. So I don't know if you work, Guy, you work for partners with specific needs, right? You also, Jason, work in this way, but you solve the needs of the people. Or you try to, right? Emmanuel is more, I would not say naive, but you don't want me to say you're naive? Naive?
That's fine.
That's fine. This is okay. But what is interesting that there are different strategies that are much more common to the standard work that is done for plants, for example. What is important is finally to bring the product to the market. So from this session, we can say that we have a huge source of microorganisms, as Emmanuel told us, with a lot of very specific activities, right, Guy? And even things we do not think about, such as pollution. I would say that 5 years ago, I didn't know about the way to destroy oil in the water and so on, the pollution. So this means that we have in the seas a huge amount, a huge biodiversity that just waits for us to valorize. Well, thank you to all of you, and I think it's okay now. Thanks a lot for being here. Thanks.